Good afternoon and welcome, Yes Prep families, to our second workshop with the one and only and amazing Dr. Crystal Collier. Tonight's topic will be about substance abuse and the brain. So without further ado, I will hand things over to Dr. Collier.
Fantastic.
And as she's setting up, just to note, of course, this will be recorded. So if you have other friends and family members who might benefit from this presentation, please note that they will also have access. The link will go out in this week's family update. So please spread the word so others can benefit from her knowledge and life experience.
All right. Welcome. The title of my presentation tonight is The Neuroscience of High-Risk Behavior. And for some of you guys who may know me, I think you also know that I'm a person in long-term recovery, as well as a therapist, an educator, and an author. I started off engaging in high-risk behavior when I was about 11, 12 years old. I had some family issues. My parents got a divorce around then. So I've got to again shut my auditory. Okay, that ought to help. Okay, hopefully you guys can still hear me as I share this, but I turned my system on mute so I wouldn't hear myself speak. So tonight we are going to learn all about how brain development is affected by substance use and how we get addicted to various things. I started studying the adolescent brain after I got sober February 3rd, 1989, which is this picture of me at the end, taken the day that I graduated from my rehab. When I went back to college, I started studying everything I could get my hands on about the teenage brain, and I learned some pretty interesting things. This is one of my favorite studies, which shows that the younger someone is when they start using the substance, the greater risk they have of suffering from an addiction as an adult. Now, this is on top of their genetic risk. But I also learned that if they just delay, if they decide not to use alcohol or substances until later on when it may be legal for them to do, they almost completely eliminate their risk. I wanted to know why just waiting really helped you avoid problems with addiction as an adult. And here is what I found out, is that during this particular phase of brain development, from 11 to 25, we're growing a lot of neuronal connections. At 11, we have 200 billion neurons, but we're actually getting rid of a lot of cells to make room for more connectors. By the time we're 24, 25, we end up with 100 billion neurons, but they're really well connected. This is a picture of what it looks like. This is an infant neuron. And as that infant's neuron grows, it starts to grow those connectors, which kind of look like tree branches and tree roots. As our neurons start to grow and develop, this is only to age 2. Can you imagine what it looks like at age 16? You wouldn't even be able to see through the network of neurons because they'll be so well connected. Those connections are taking place here in our prefrontal cortex. It's really critical to know that this is the part of the brain that's growing and developing as we age. And it is such an incredibly part of the brain. And it grows based upon the use it or lose it principle. Every parent, every teacher should know this principle. It basically says the cells that you're using for executive functioning in your frontal lobe grow if you use them, but they don't grow if you don't. These are the lower level executive functioning skills that grow from birth all the way up through middle school. Those help us get organized, remember our lunch as we're getting out the door, making sure that we stay on task. Then we hit around age 11, 12, and we start growing higher level executive functioning skills. These are the ones that really start to peak around high school and college. And these are critical executive functioning skills because these are the ones that we need to be able to have empathy for other people, solve problems and make decisions on a very mature, adult-like way, control our impulses, and have good judgment. Parents, please remember, when you see your kids using these skills, use brain-based praise and reward them. And make sure you don't over-function for your kids. If you do too much problem solving or make too many decisions for them, they're going to have long strings of neurons in their brain for being dependent upon you, and not long strings of neurons for good judgment, for problem solving, for independent decision making. This is a critical part of the brain that now we're going to explore how substances like drugs and alcohol and some other behaviors like technology and pornography use affect the brain as it's going through this critical growth process. So let's discuss how this happens. It happens in another part of our brain located deep within our lobes, known as the limbic system. Most people know this part of the brain is the fight or flight part, but it's also the part of the brain that governs all pleasurable experiences. And that happens because of this brain chemical called dopamine. Dopamine is the chemical that our brain uses to signal reward. When we do something good for our survival, we get an instant shot of dopamine in our brain that tells us you're on the right track, you're doing good. It then makes you feel calm and happy. Think about how you feel after you have eaten. You get that sense of well-being. But let's say you forgot your lunch. It's been about 6-7 hours. What happens is that your limbic system starts depleting itself of dopamine. It's basically saying, hey, you need to go eat. And until you do, I'm going to make you feel really uncomfortable and take away all your dopamine. Then you get tunnel vision, hangry, irritable, can't think about anything else but food. Your brain says, you need to only think about what's good for your survival. And as soon as you eat, you get a 100% increase in dopamine. Your limbic system says, hey, good job keeping me alive for the next 4 or 5 hours. We'll do it all again later. But in the meantime, feel calm and happy. You did good. There's another human behavior that, of course, we wait until we're married or at least protected. When human beings engage in sexual behavior, we get a dopamine increase of 150%. This is because sex and sexual behavior is not only good for our survival, but good for our species' survival. And that's why scientists believe we actually get a lot more dopamine from sex than we do from food. And if you guys think about it, this is kind of what humans do on a great date night. All of that dopamine. Yep. But remember, you guys, this is normal, natural dopamine spikes. There are substances out there and behaviors that spike dopamine levels way too high. For instance, cocaine. Somebody who snorts a line of cocaine increases the dopamine in their brain by 350%. If they use the exact same amount of methamphetamine, they get a dopamine increase of 1100%. Oh, the brain can't handle this influx. I learned that heroin can increase dopamine levels by 1300%. I tried to put that on this chart, but then you couldn't see food or sex anymore. And that got me to thinking, that makes a lot of sense. What happens when somebody actually starts using heroin or opioids? Once their brain gets addicted to those substances, they stop wanting food or relationships or sex. Their brain gets hijacked. Now remember, your limbic system is just that fight or flight survival part of the brain. It's a reactor. It's not a thinker. The part of your brain that is the thinker is your frontal lobe. Now, the reactor, the limbic system, it does a simple mathematical calculation. It basically says, hey, when you put this in my body, I get 250% more dopamine than when you put this in my body. So that must mean this is 250% better for my survival than that. Huh, not true. But your limbic system doesn't know that. It simply does a calculation. Now, it's important to remember that not everybody processes dopamine the same way. We have a threshold for dopamine in our brain. Scientists call it the hedonic threshold, which is a word that means pleasure. That threshold is right about here. Our dopamine levels go up and down within that threshold all day. I mean, think about it. If you get hungry, your dopamine plummets, but you eat and it goes back up. If you get bored or lonely, your dopamine may plummet, but then you connect to people, smile, communicate. All of those things increase dopamine levels naturally within this threshold. The danger is when you spike your dopamine levels above the threshold with things like cocaine, alcohol, marijuana, amphetamines, methamphetamines, all types of illicit drugs and different behaviors that also spike dopamine too much. When we go above this threshold, two things happen, two structural changes. Let me show you the first one. In this video, we are traveling deep inside the limbic system. You can see your fight or flight part of the brain, and we're going to look at the neurons and the receptor sites. What you see is dopamine coming across the synapse, binding to the receptor sites. But when you use something that causes your brain to produce too much dopamine, it depletes the cell of dopamine and then it can't produce the same amount. This is why, as high a drug takes you, it will take you equally as low. That can cause structural damage to those little neurons in there, hurting their ability to produce the same amount of dopamine. Now, the good news about that structural change is that your brain can heal. If you think about it, if you've ever had a hangover after drinking too much, you know that your dopamine levels are low for 1, 2, maybe 3 days. But after you get hydrated and get some more dopamine from food in your system, get some rest, your brain starts to heal and you go back to producing the same amount of dopamine that you did. But if you keep doing that to those cells over and over and over, that structural damage could remain permanent. Now, let's move on to the second structural change. When you flood those synapses between the receptor and the other cell, when you flood those synapses with so much dopamine, your brain says, oh, I gotta grow more receptor sites. It grows more these dendrites that reach out to other cells, making more and more and more receptor sites like these. More and more receptor sites for dopamine means that your brain has the capacity to feel more of a high. We call that building a tolerance. But here's the bad thing. Once you create way too many receptor sites, and now all the dopamine leaves your system, you've got all of these new receptor sites in your brain craving, screaming out for more. And that's when you go into a withdrawal for a few days, for maybe even a few weeks, depending upon the substance. But now you have a tolerance. Now your brain wants more. And so maybe you use a little bit more than you used to, but then you grow new receptor sites and you can see the problem. More and more and more means your brain becomes addicted. Now, the negative thing about that structural change is those structures don't go away. And this is why we have a saying, once an addict, always an addict. Those brain structures stay there. And so the more you use, the more you go over your threshold, the more addicted your behavior and your brain can become. Now, here's what is important about the hedonic or pleasure threshold. This is a line, this black line here, that represents most people. But about 1 in 5, 1 in 6 of us have the genetics for addiction. Does it run in your family? For me, it runs on both sides of my family, my dad's side and my mom's side. My genetic risk is really high. Yours may just be from one side of the family, and your genetic risk may be a little lower. But if you have a genetic risk, this is not your threshold. Your threshold might be here, as represented by this red dashed line. As a matter of fact, geneticists have figured out that out of the 30,000 genes that we have in our chromosomes, about 2,200 of them have been related to addiction and mental health problems. You can actually get a genetic test, which I'll tell you how to do that at the end, to literally find out what your genetic risk is and whether or not you have this, the reward deficiency syndrome. This is something that my genetics actually show me that I have. I have RDS, which basically means that I have enough genes in my chromosomes that tell my brain to actually make a little bit less dopamine than other people do out there. What that means is when I ingest something that makes dopamine spike, it actually makes me feel kind of normal. But my threshold for those structural changes is lower. Let me give you an example. I met a girl quite a few years ago. Her name was Caroline. She came to me and said that she saw me do a presentation at her middle school and she loved it and stopped smoking pot for about a month. When I asked her why did she start up again, she said, well, you know, my grandparents who had custody over me weren't really watching and all my friends were starting to use it, so I tried it again. But my friend, she never had consequences from it. But I always got caught. I always got sick. I don't know. It was just like I processed it different. Her friend most likely did not have any of the genetics for addiction. But when I asked this young lady, did it run in your family? She said, oh yeah, that's why my grandparents have custody over me. Both of her parents were addicts and lost custody over her. Genetically, she had a lot of those genes that told her body to make less dopamine. And so even though her and her friend were using the same exact amount of dopamine as might be represented by this spike, her threshold was lower. That means her brain started making those structural changes at this red line, and her best friends didn't. She didn't use enough to make those structural changes. This helps us understand why two people can use the exact same amount of a substance, one becomes addicted and one doesn't, because the genes of that one person cause that person's hedonic threshold to be lower. All right, you guys, let me show you what it looks like in the brain. This is important for parents to understand, because when youth use underage while their brain is growing and developing, it can shut off their frontal lobe, and this is a picture of it. This is a functional MRI looking from the top down, and what you see is a brain who is completely sober. The top brain here shows electrical activity and blood flowing, as evidenced by the colors, in all parts of the brain, especially right there in the prefrontal cortex. The darker the color, the more activity. This person is completely high on a substance. And what you see is the limbic system area turned on, full of dopamine, processing all of those happy, well-being feelings. But look what happened to the frontal lobe. It turned off. Now, if you do this to yourself because maybe you overate, or maybe you drank too much, or maybe you engaged in too much video games, if you do this to yourself as an adult for a few hours, maybe a few days, it may not hurt you like it would a teenager who is developing that part of the brain between the ages of 11 and 25. If your frontal lobe is off, does it get to grow? And the answer to that is no. It doesn't get to grow at the same capacity that it did had it been completely sober. Now, it's important to remember, if somebody starts using here at about age 12, and they keep going and going and going, and they decide to stop at the age of 20. If we took a picture of their frontal lobe, it wouldn't look like this normal frontal lobe. It may look more like this 16-year-old. And if they were a regular user every day, every other day, it may even look like this 12-year-old's frontal lobe at the age of 20. I want you guys to think about that, because you probably know an adult or two who did this. Their frontal lobe skills, those executive functioning skills, are probably not as high as they should be. They may be much lower. If they are, that is the baseline that they have to work with for the rest of their lives. So, always important to remember, it takes time to heal. We don't want our kids using, and if they do use, we want them to stop as soon as possible. And if you're an adult who knows somebody who's trying to stop, please be patient, because it takes time to heal, as shown in this slide. In the middle, you see a cocaine abuser who's been sober for 10 days. Notice their brain is on in these back areas, but the frontal lobe is still off. This person is most likely in detox. All of those extra structures in that person's brain are screaming for that drug that the limbic system got hijacked into thinking it needed to survive. But look at this picture here. Even at 100 days sober, the frontal lobe is still not all the way back on. It may take up to 18 months for it to return back to normal, and if it was a more addictive drug like heroin, it could take anywhere from 4 to 5 years to return to a more normal level of functioning. The good news is the brain does heal. The bad news is it takes time. And we may not have that if we're growing our frontal lobes. So let's talk a little bit about some things that cause dopamine to spike pretty high. All chemicals of abuse that we know of spike dopamine levels at varying degrees. I picked out a couple that our teenagers are struggling with. Of course, alcohol is the most widely abused substances underage, and this is a really great study that shows the effect. These are two functional MRI studies of two 15-year-old boys. One is a non-drinker and one's a heavy drinker. Both of these boys were doing a memory test while they were in the functional MRI machine, and you can see big differences. There's a lot more blood flow and electrical activity in our non-drinker's brain. That's pretty obvious. But look at the more subtle differences. You can see all those long strings of neurons causing those folds to be created in this person's brain. But not here. You can see the effects of arrested development. This brain is not growing those long strings of neurons that then fold into each other, making those goofy folds and wrinkles in your brain. This kiddo is suffering from arrested development. This child over here, the non-drinker, is probably functioning at a 15-year-old frontal lobe level. This child is probably at a 12 or 13-year-old level, depending upon how long ago he started drinking. Now, we know alcohol can hurt us, but what about marijuana? So many states in the union are now creating legalization laws. What's interesting about this is that the lobbyists who are lobbying for this are all employed by big marijuana and big tobacco companies. They want to get you hooked so they can make money. So one of their tactics is to increase the potency of marijuana by genetically modifying the amount of THC, tetrahydrocannabinol, in the actual plant, increasing it genetically, making it much, much more potent and more addictive. The marijuana of today is about 4 times more potent than what it used to be. And here's a good study that illustrates this. From the Amen clinics, it's a Spect Scan, which shows brain connectivity and activity. This one is from the bottom of the brain up rather than the top. What we see in a normal healthy brain is a smooth scan, which shows you neurons that are really well connected and activity moving all throughout the brain. The two scans here on the middle and the right show 16 and an 18-year-old who have a regular marijuana use issue. Now what you see is that there are what looks like holes in the brain. They're not really holes, they're areas that are just not connected. There's no blood flowing and electrical activity moving across those areas that look like holes. The scary part is right there, the prefrontal cortex is really underdeveloped. Now these kids are going to grow up and be able to function in the world, but they're not going to be able to function at peak executive functioning capacity, much lower. We know from decades of marijuana research that chronic use of marijuana affects memory, attention, visuospatial skills, arrest executive functioning skills. Those who use marijuana long-term on a very regular basis show up to 8 IQ points less than other kids who never use or who use on a very sporadic basis. Even the kids who grow up with chronic marijuana problems make less money than other people out in the world do. And sadly, they also report less satisfaction out of life. Remember, you guys, the word medicine has been used by the marijuana industry to sell their product. It's not really a medicine. You don't go to a liquor store to get your medicine, just like you don't go to a marijuana dispensary to get medicine. You go there to get a drug, a highly addictive drug. And today, marijuana extracts made from hash oil resins are even more addictive than other green leafy buds. This, called wax, shatter, or dabs, put into a vape machine is about 4 times more potent than the actual marijuana plant itself. All right, let's switch over to behaviors. We know that engaging in lots of other behaviors out there in the world can increase dopamine levels. Eating good food, having good sexual relationships, smiling, communicating, all of those are good for our survival, so they increase dopamine. The danger here is when we increase dopamine levels too high. These things can also become addictive. So it is critical that you teach your children balance and set limits not to engage in risky behavior until their brain is fully developed and they can perceive the risk accurately. I picked out a couple of these that are big issues for our kids today. The first one is food. We know that broccoli increases dopamine levels, especially if you're hungry, but probably not to the extent of cocaine or definitely meth. But high carb, sugar dense foods can increase dopamine levels above your hedonic threshold, unlike broccoli, causing the same type of addiction to dopamine, but this time it's from food. This is a study that shows a brain from the backside looking forward. This person just ate sugar. They do not have food addiction, and you can see their brain lighting up in various places because their brain likes sugar. The next slide is a brain scan looking from the back forward of somebody who is a food addict right after ingesting sugar. Their brain lights up, both sides of the limbic system completely lit, full of dopamine. If we turned that brain around, you would see their frontal lobe going dark. A lot of people can relate to this. If you overeat, like especially on Thanksgiving, you know that you don't really want to engage in a lot of frontal lobe activities. You don't want to have a lot of empathy or do complex problem solving or decision making because you're in a food coma. The bad thing is that when our kids develop overeating or food addiction problems, their frontal lobe doesn't get to grow. So they don't get to make the best decisions, especially about things like eating healthy and exercising. Technology has become a big issue. This is an internet cafe in China. Technology has affected Asian countries about 15 years longer than it has us. The good part about that is we can study their culture to understand the negative effects as well as the positive of technology. They've even had to install technology walkways because people won't look up from their technology and get hit in traffic. This study shows two different groups of adolescents who underwent brain scans. These researchers wanted to find out what type of connectivity these brains had. If you were to connect all the red dots, you would see the brain connectivity of a group of healthy adolescents who only use the internet for a few minutes a day, as compared to the purple lines, which indicate the brain connectivity of a group of adolescents who were on the internet for 12 or more hours a day. There is a syndrome called Hikikimori Syndrome, where Asian kids are just dropping out of life, staying on the internet all day, not working, not being productive, suffering from depression and isolation. And because in many Asian cultures, it's taboo to ask for help, to reach out to therapy, they just don't. The parents shut them off and forget about them. Over 1,000 young people have been diagnosed with Hikikimori Syndrome in Japan alone, and we are seeing this happen here. I have to tell you guys about every February and every October, I usually get referrals from college kids who went to college but failed because all they did was stay in their dorm rooms and play video games. Here's the last behavior that we will talk about, and this is critical because 70% of 13-year-olds and up are using pornography today. 70%. With the invention of high-speed internet and the accessibility of the internet, we see more and more kids using it. There was a study that came out that showed snorting a line of cocaine increases dopamine levels about 350%, which is about the same amount as watching pornography for a half hour. But remember, you guys, that sex happens in our brain before it happens anywhere else in our body. So if a youth uses a screen with pornography to get an erection over and over and over, they get a dopamine spike. That's right about here from porn. But remember, real sex only spikes to about here, 150%, as opposed to 350%. And when that happens, other parts of the body fail to work. We see more young people getting diagnosed with erectile dysfunction today than we do older people 65 and over. And this is not just affecting boys, also having a negative impact on girls. Remember that just like drugs, porn can damage those neurons and have negative effects on all parts of our body. All right, you guys, start getting your questions ready. We're going to move into what do we do? What does prevention and recovery look like? It looks like this picture. Making sure that your children's neurons are growing those long dendrites that reach out to other cells, making networks for those beautiful executive functioning skills so that you make better decisions when they're older. Also making sure that you use what prevention science says helps keep those executive functioning skills working. Brain-based praise, and here's your list of things to do. If you have addiction in your family, please get your child genetically tested so that you know what their risk is. Consistently educate them at school and at home. Make sure you involve your children in pro-social activities. More kids end up using substances and getting addicted to technology when they don't play sports or they're not required to be in an after-school activity. Even if your child doesn't play a sport, they can join a theater club, a math club, the debate club, or they can do a volunteer job after work, or maybe even a real job. My first job was working at Arby's when I was 16 years old, and I couldn't wait to do that. It is really critical they stay in pro-social activities. As soon as they want to get out, you let them know that they can switch. They have to be in at least one pro-social activity per semester. You also want to create a family code, which I'll show you in just a second, and teach them refusal skills. Make sure that you go through the list of high-risk behavior and ask them, what would you do if? What would you do when? Let them come up with all kinds of refusal skills. You can also do drug testing, which is the #1 refusal skill. In my book, I actually have a whole section on drug testing, how to present it to a child, and where to go to buy the tests. If you drug test your child once or twice every year, they go to parties and they get to use the #1 refusal skill. Oh, my mom drug tests me. Oh, my dad's going to test me as soon as I get home. And the other kids are going to show empathy. Oh, dude, I'm so sorry. But your kid comes home sober. You want to make sure that you eat dinner as regularly as possible. Research shows that when family dinners start to decrease as kids get older, high-risk behavior goes up. But if you reinstitute family dinners, high-risk behavior starts coming down. And it doesn't have to be a big deal. It can just be a tradition that you have that 3 to 5 times a week you eat together. Even if it's going to your favorite fast food drive-in and getting the low-carb food options and talking in the car before soccer practice. Remember that family dinners help create unity and give you lots of options to talk to your kids and lay down your expectations. Make sure you also give them consequences. One of the biggest mistakes that I see parents make is that when a child engages in substance use the first time, they get a slap on the hand. They get told, oh, it's just a phase, it's no big deal, don't ever do that again. It's better to go big. A big grounding, a big consequence, letters of restitution. Make sure they get involved in proactive community action. The more they're active in their community, the more responsibility and empathy that they'll have, the better they will take care of themselves and their environments. And you guys, if a problem happens more than once, go to a counselor, a therapist, a treatment center. Yes Prep has one of the best counseling staffs that I've ever seen in a school environment, and they are equipped to help you deal with this issue. Let me share with you how to build a family code. Sit down with your kids, no matter how old they are. If they're younger, you could actually get out the crayons and a poster board and create one of these. If they're older, you may just want to do it on your computer. A family code is a really short sentence, maybe 2 to 3 sentences that represents what your family believes in and what are some of the things that are off limits. In my family, we treat others with kindness, compassion, and respect on and offline. We take care of our brain development. We don't ever use drugs, and we only drink alcohol when we're 21 or over. You hang that on the wall, and once every month or so, you mention it at family dinner. You ask your kids, hey, have you heard about vaping? Hey, do you know anything about pornography? Hey, did you hear about this? Well, that wouldn't happen in our family because we have a code. Oh, what happens if you break the code? Yep, you'll get a consequence. Hey, you're going to that dance tonight, or you're going to a sleepover. What's the family code? And when your child says, oh, Mom, the family code is la, 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 la. When you hear that, that should be music to your ears, knowing that your child has memorized the code. Research shows that it makes kids feel unified as a family unit, and that makes them want to uphold those values even more. Here is the genetic addiction risk score genetics test. Please know that I do not have a relationship with Genus Health. This just happens to be where I got my genetics test. There are other companies out there that do this, but Genus is the only one that gives you a genetic addiction risk score. It'll tell you what percentage chance your child or you has genetically of struggling with addiction, and which neurotransmitters out of 10 of them your brain actually makes less of. The nice thing is Genus actually gives you recommendations for natural supplements that you can take to naturally increase your or your kids' dopamine levels. If you would like a copy of my slides, I would be happy to share them with you so that you have my references. And I've got really great news. The Spanish version of the Neuro Whereabouts Guide, Guía de la Neurolocalización, is out. You can purchase either one of these, English version or Spanish version, at Amazon. And every time you come to one of the Yes Prep presentations that I'm doing this month, you will be entered into a contest to receive one of these of your choice. Okay, I'm going to unmute myself so that I can hear you guys and figure out if we have any questions.
And Dr. Collier, as I'm looking here, hopefully you can hear me, but one of the questions around the THC content in marijuana, as a former principal, I can relate to this. How do you know how much THC is in the marijuana? Or if it's a vape pen, how do you know what the liquid content is to be able to identify what the substance really is?
I'm so glad that you asked that question. The answer to that question is we don't. You won't know. There are not a lot of organizations out there that are testing THC levels. You just don't know. I've been treating a lot of adults, started off just smoking marijuana 2-3 times a year, really truly recreational users. But their drug dealer turned them on dabs, and all of a sudden they became so addicted that they were using 6 to 8 times a day. You don't know, as a principal, that if you find marijuana or a vape on a child's possession, if it's marijuana or not, and if it's a hash oil product or not. You can go to a laboratory in the city and have it tested, but it's potentially expensive to get that done.
Thanks. No, yeah, it's such a tough issue for parents and principals. Another, you already answered around the getting the book in Spanish. That's very exciting. Eager to add that to my library as well. With 70%, what age did you say of younger kids that are using pornography?
Yes.
Of what age?
13 and up.
Okay.
As young as 13 are using it on a regular basis.
And given that terrifying statistic.
What we know, though, is that the first accidental exposure to pornography in our country is on average about age 9.
Right.
The first search for pornography is about age 10, which makes a lot of sense because you get curious and then you search it. But by the time you're 12, 13, 14 years old, you may already be using it regularly, which can have a deleterious effect on your sexual identity development and your sexual performance as an adult.
Do you have any recommendations for parents in thinking about, there's different restrictions you can place on technology, but it seems like it's almost a losing battle as far as just the access. Do you have any recommendations?
Yes, my recommendation is the technology Bark, B-A-R-K. There are some other programs out there, but if you download Bark and some other technology onto your child's phone and their computer devices as well as tablets, you can download it onto all. It will search your child's technology activity via an algorithm. And when it spots that your child has looked at a pornography site, it will send you a text that says your child just looked at this site. And of course, then you go limbic and you panic. And so the nice thing about Bark is it gives you an idea of what to say to your child about that. Then you can go back and refer to the family code. Maybe you put that in. That we don't do that to our brain. We protect our brain from all things, including things that can spike dopamine levels too high, like pornography.
Another comment around the family dinner, and thank you. The suggestions there are wonderful. And I just wanted to invite Jonathan to share about ACE for those families and the idea of encouraging after-school activities. Jonathan Reyes is also on the call. Jonathan, do you mind unmuting and just sharing a little about ACE?
Yes, definitely. Thank you, Barb. My name is Jonathan. I am the Family Engagement Specialist for the ACE program, and I think Dr. Collier mentioned a little bit about it. We provide after-school opportunities for students, ranging from classes about STEM, sciences, mathematics, and in-classroom education in a more fun and exciting way than you would actually learn in during the regular school hours. We also offer family engagement activities for parents, and such as Dr. Collier's session, and many other sessions that deal with college readiness. So that's a little bit about the ACE program, and I look forward to hearing from you all.
Thanks, Jonathan. I think you can hear me.
Yes.
Yes. And so just delighted that we were able to host these workshops in collaboration with our ACE After School Centers and Education program. Jonathan has been a tremendous asset, and Dr. Collier, we couldn't be more delighted to have your expertise and your willingness and vulnerability to share your story and help all of our parents and families to think critically about the brain development and how they can help support at home. So again, I didn't introduce myself at the beginning, but Barb Campbell, the Director of Family Engagement, thank you so much for participating this evening. We will ensure this is available to all families who are not able to attend the Tuesday after spring break. And thank you all so much. Have a great evening.